Ya.
¿Qué?
¿Esperamos a alguien más o ya te doy? ¿Cómo esto?
Esperamos un poco.
Sí. Han desaparecido. Creo que Antonio ha recuperado 3 o 4. Faltan 3 o 4 más. No? Okay. So, welcome everyone. I'm Carlos, and I'm going to present you some overview of how to install and compile in your computer the developer version of Kratos. If you remember, we've said that Kratos can be used by developers, by users, or by advanced users. So this kind of installation is the one that you should use if you want to modify the code or you want to make use of the advanced features of Kratos. So, Kratos is a multi-platform code, so it can be compiled in Windows and Linux, and I'm going to go through both options. And finally, I will show you some references with more detailed instructions in case you have any problems during the installation and so on. So we're going to begin with Windows, and the first thing that you will need to compile Kratos under Windows is a compiler. In our case, we choose Visual Studio. There are other options, but we are actually using this. We recommend you to use the 2012 version. That is the most recent one that we are sure that it's compatible with your code, so you will not have problems with any external library or any kind of incompatibility if you use this one. You can download it for free with the Microsoft page, but you should keep in mind that with this version you will not be able to use the parallel features of Kratos. So in case you want to make use of these parallel features, you will need the professional or ultimate version that maybe your center or your university have for free. So you can choose whatever version you want. Well, we have several ways to compile this version. In fact, if you go to the Kratos wiki, you will find an in-depth tutorial of how to do that. But we found that this is somehow hard to follow by people that are not used to compile big applications under Windows. So we recently developed an installer that it's more or less makes all the steps that you otherwise should do by hand, but it does it automatically. We have a version for 32 bits and another version for 64, but you should know that if you find any kind of problem with the 64 version of this installer, the 32-bit version works on any machine. So if you are not sure of what installer you have to choose, go directly to the 32-bit version. So this installer, as I said, will automatically install all the dependencies you will need, like Boost, Python, Subversion, everything. It will download the code of Kratos as well in the location you will put, and it will automatically compile the code. You also have to know that if any of these steps fail, you can also do it manually. So this is not an installer like we are used to use, but some kind of a guide for you to make this process easier. So when you download the installer, that you can find the links in the Wikipedia as well, you will be prompted with a regular screen. You will only have to select next. You will be displayed the license agreement. As Antonio said, it's completely free. You can do whatever you want with the code. and it will ask you for the path to install and download all the code. When you have chosen the path, I will recommend you to leave this one if there is no problem with it. You will be prompted with a screen to choose which features do you want to install. As you can see, all they're appearing in gray and also checked. This is because the installer is not finished, and we prefer just to install everything that is needed except Kratos. So if you want to compile Kratos by your hand, you can also use this installer only to set up all the dependencies. And well, after that, the installation will begin. So you first will go through this screen. This screen will indicate you in which step you are. For example, it starts installing CMake, that is the tool that generates the Visual Studio solution. Then we'll be installing Python and all the other things. And when it ends, you will see these screens. We are unable to hide the X button, so please don't click it because it will crash everything. Basically the first screen that you will see is the one that will download the Kratos code. And after that, you will be prompted with this other one that compile the code. So compiling the code is a really slow process, so you have to keep in mind that Kratos is really big, and it will take approximately from 1 to 2 hours. So it's normal if this process takes a lot. At least the first time. You can run this installer multiple times if you modify some part of the code or whatever. Basically, this when it ends, it will show you the process has ended. That should be everything under Windows. So we have tried to make the installation and the compilation process as easy as it could be. Just to say you, when this is finished, you will also have the Visual Studio project if you are familiar with it, and all the configuration files in the directory where you have downloaded Kratos. So you're free to use this again, or if you prefer to make use of the regular tools. So this is just a tool to make your life easier if you try to install Kratos. For the Linux part, it's not that easy. So the Linux part will be more hands-on. And as in the Windows version, you will need to install a series of requisites, but in this case, you will have to install it by hand. So we don't provide any tool that install all the dependencies with the correct versions yet. So most of the distributions also contain the library. For example, most of the Linux distributions that you can use also have Python installed with the version 3. That is the recommended one because we are moving to Python 3. And for the other libraries, you can use the regular packet manager of your system. I put here 2 examples for the Ubuntu and Fedora that I think are the most popular distributions of Linux. And in the Wikipedia you also have the complete list of all dependencies that you need to install. There were too many to put it in one slide. So I just want to make sure that you know that you have to install everything before you can compile Kratos. I like to put Kratos, I boost here apart because it's a little tricky to install. You cannot install Boost using the packet manager, you have to compile it yourself. This is because most of the distributions come with a version that is too early for us. So we will need to install Boost 1.55 at least. And for do that, it can be a little tricky because Kratos Boost is an immense library that has many features, but we really only need 2 of them, which are the Python wrappers, the .kit, and the serialization library. So we can easily skip to compile the other things if we follow this procedure that basically is to put to prepare the things that it's done calling that bootstrap script. After that, it will generate some files and some executables. you have to modify the proprietors at the project configuration jump and add this line. This line is important because with this line you will tell Boost which version of Python to use. So this is source of many problems that people have, and you have to make sure that the version that you're using to compile Kratos is the same that you use to compile Boost. Otherwise, it will give you problems and Kratos will stop running. So, well, apart, you can find more information about how to compile Boost in Boost documentation. That it's really complete. So there is no much problem. So, well, when you have all the dependencies installed, the only thing that remains to do is to obtain the Kratos code. That, if you remember, in the Windows it's done automatically, but well, in Linux is so much easy to do. You just only have to call this subversion command. It will create a repository and download of the Kratos code there. So I have put a screen here to show you more or less what you will see. It takes a few minutes, 1 or 2 minutes maybe, to download all the code. And after that, you will have to go to a Kratos immutable directory. There you will find 2 templates for configuring the Kratos compilation. One is for Windows, another is for Linux. You have to choose the one for Linux, and you will need to modify some parts over this file. So this file basically contains 2 different things that are the paths and the applications that you want to compile. For the paths, you will have to put the paths of your system. I assume that you are more or less familiar with Unix environments. So, for example, if we are installing Kratos on our home directory, we'll have to put here, for example, slash Carlos, which is my name, slash Kratos. That is where Kratos has been unloaded, and activate or deactivate applications to make the process maybe faster. So if you are going to work only with the structural problems, you only need to activate the structural applications. But as a guide, the most common applications are activated by default, and more advanced are set to off by default. So, but you're free to turn on and off all those applications. Then the only thing that you will need to do is run this script. That the usual is to name it configure sh. And if by some chance, or well, it tends to happen that you're missing some path or something, CMake normally says you that it's not able to find Boost or is not able to find Python, but it also will tell you which variable of these ones do you need. So typically, one of the things that it's hard to find is Boost. So for example, you can put the Boost root and put the root of your directory. But if you install everything in the default path, should be no problem. So, well, more detailed instructions that I'd explain are in the wiki. We have a wiki for both Windows and Linux. You will see that are different. In the Windows version, you can also find the hard way to compile Kratos under Windows, but you will also find the links to automatic installers. And in the Linux part, you can find all the list of the requisites that you have to compile previously to compile Kratos. And well, of course, if you have any doubt, do not hesitate to contact any of our staff or me directly. I'm the one that manages everything. Well, thank you for the attention. If you have any question or okay. Sí, es verdad.
empieza ya? Okay, hello everyone. I am Miguel Ángel. I work here in TeamName. I'm a researcher. And I got into the Kratos team more or less 2 years ago to code a DEM application for calculation of granular materials, etc. We decided to move into Kratos because we knew that we would be able to communicate easily with structural applications, with fluid applications and stuff. So in general, every application is destined to communicate with others at any point. And so I will talk about the philosophy of the design of Kratos. And I've been chosen to do this talk because I'm one of the latest people to get inside Kratos. And probably I have a concept more similar to someone that doesn't know the deepest part of Kratos. So I'll talk about general concepts, not about names of functions, not about classes or templates or anything. I'll talk just about concepts. Okay, this is the outlook. I'll talk about the design principles of Kratos and what can Kratos do for you. Also about the description of a model and how we have decided to implement discretization of finite element code, and then how a problem is simulated, and about the components that we can manage to get to a solver that can be useful for us. And at the end, a global workflow that will explain more or less how an application starts to run. And this will be basically the introduction to the next talks that will get a little bit deeper into these details, how an application starts to run and calculating. Okay, what were the goals of Kratos from the beginning? This is important. It was designed as a tool for finite element problems. There has been, I think, 10 years of development. It's 10 years of development, and some mistakes were done, and some corrections were done according with the needs that were appearing with the finite element problems. But the goals were this I'm going to show. Kratos must be flexible from the beginning. Flexible means that any application, it doesn't matter whether it's for heat transfer of fluid or structure or particles, anything can work with Kratos. And it doesn't matter if you are calculating a velocity or pressure, anything. So it must be very flexible. All functions must accept arguments that are general enough to deal with different things. It must be extensible. It's not for one use. It can be used for many different things, so it must be easily extensible. That means that when you extend Kratos, you don't need to change the previous things that are in Kratos. This is what we understand for extensible. Reusable. If you have a function that solves a linear system, you don't need to write another one, even though it's for a different application. So all functions must be reusable. They must not have names like velocity or pressure. They must have names like get or set or calculate or solve or these kind of things that are general and can be used from different applications and different concepts. And it must be efficient. This is why we have this mixture between Python and C++. The general functions are called in Python, which is not very fast, but everything that takes time is programmed in C++. This is why we say it's efficient and it's parallelized too. Okay, the intended users are finite element developers. If you want to write your own application that calculates something with finite elements, you have a background of advanced mathematical engineering tools. You have builder and solvers. You have assembling tools. You have these kind of tools that are necessary for finite elements. and computer science knowledge. Parallelism is already inside. Some software developers might need a core or an application that could be inserted as a piece of a more general software. And then we can also have package users that don't want to know anything about codes, don't want to know anything about Python or C++. So we can use Kratos as a black box for this kind of engineers or designers. The general design is always object-oriented, even in memory. In memory, it's allocated as object-oriented programmation. We have objects. We have generally the interface that lets you to get information from an object, from memory, and save it also. And usually, these objects are based on common finite element concepts. That is, when I got into Kratos and I wanted to program the DEM actually is a program for particles tracking. And actually I'm using a node for the center of the particle and an element that is used for basically storing information. So I'm using an element which has only one node for DEM, but actually an element can have as many nodes as you want, like in classical finite element codes. The main programming language is C++ for efficiency reasons, and it supports object-oriented design, C++, and high-performance code. And the multi-layered approach is exactly what I was saying. We have C++ underlying, but everything is called from Python. High-level code, which would be Python, that is calling continuously C++ functions that are much faster than in Python. Then, this kind of objects is what we have in Kratos. This is like a cloud. There's some classifications, library interfaces, where we have the kernel, basic functions that are used in everywhere of Kratos. We have the applications, I/O functions to write or to read from input files. We have processes, strategies. I'll talk about them later on. About the modeling, we have model parts. These are subdomains. We have meshes, spatial containers. And these are probably the most important objects of Kratos, probably because we have a node which is storing a lot of information. We have the element storing a lot of information and functions and everything. Properties are used to store values of materials, etc. And basically, here is where we store most of the information. And then we have other numerical solutions that are used in a lower level to access memory or to call some functions. Then, I think this is the most important slide of my presentation. This slide was written by Pouyan, who is one of the creators of Kratos. It's in his thesis, in his PhD thesis, and explains very well the importance of hierarchy and dependency, because all the things that are up in this scheme are more general and can call things that are in a lower level. But the things that are in lower levels cannot call objects that are in upper levels. So following this design, for example, a strategy that would tell us how to calculate a system of equations, how to assemble it, everything, can work on a mesh, can work on model parts, on subdomains, on the whole model, can work on these kind of entities. These entities can call nodes to assemble a matrix, can call elements, functions of the elements, etc. But an element cannot choose a strategy. This is very important. A node cannot call to a model part. it's always this way down. Okay? This is a very important scheme that has been respected from the beginning. It has its limitations, but looking for flexibility, extensibility, and all these concepts from the beginning, you cannot change this. And then there's another order, which is right and left, which would be the things that are fixed in Kratos, the objects that are fixed and belong to the kernel, and the things that you can create on your own and are customized. For example, you have standard applications in Kratos, but also you can create new applications here. So your new application can call old applications, because it could be a coupling application. I'm going to couple fluid and solids. Then I'm calling two standard applications from my application. But I will need a different strategy. So my application will not call the standard strategy, but will call a new strategy made by me. That is, it has some differences with the standard one. It can be derived in the C++ sense, so it can inherit all the properties of a standard strategy, but you can add features to get your result. And now you can create your new elements, your new conditions based on the base classes that you have in the Kratos kernel. Okay. So Kratos is a programming numerical core, and you have standard fluid dynamics applications. You have the structural mechanics application. You can have the PFEM. This would contain part of the physics of the problem, while the kernel has only numerical and programming functions. Then, if you want to create a fluid structure interaction, you'll probably need to call the fluid dynamics and the structural mechanics. This is what I was saying exactly. And you can have your own strategy, but probably at some point you will call the strategy that is inside the fluid dynamics application and the strategy that is inside the structural mechanics application. So this is very important, this difference between this level and from this point towards the lower part. Is the separation between the numerical core and the physics. What are the components of a model? Well, in Kratos, each entity stores its data. This is in the same line I was saying that it's very object-oriented. We don't have arrays of coordinate x, arrays of velocity, arrays. There's an array of nodes, of an array of elements, and each node contains its own data. Okay? Then the properties are like shared data between different elements and different containers. You may have a computational mechanics model, a structure, and you may have two materials, for example, concrete and steel. And then you could have two properties only. Only two properties, one for concrete, containing the Young modulus, the density and this stuff, and another for steel. But all elements that are made of concrete have a pointer to one of the properties, the ones that are made of concrete. All elements that are made of steel are pointing to the other property, the second property. But this object is stored just once, one for concrete and one for steel. And then in each element you contain just a pointer. Then it's important to see that a node can contain nodal data. An element can contain elemental data. A condition can contain conditional data. And it's not written here, but a mesh can contain mesh data. A model part can contain model part data. This means that every object of Kratos can save any variable at any time. You're writing your code, and you say, at this moment of the coding, I would like to save the velocity. And you can go to the nodal data and say, save velocity. You don't need to allocate space in memory. You don't need to do anything. Just store this variable in this node. or store this variable in this mesh. All objects have their space to store anything. Okay? This flexibility is not for free. This is a little bit slow. I mean, saving something